Now let us compare another set of functions, n square log n and n log n raised to 10. So here, to compare these two functions, we are going to apply log on both sides. So here log n square log n, and then when we apply log to the second function, we get log n log n raised to 10. Okay, so here we can rewrite it as log n square plus log n, and this can be rewritten as log n plus log n raised to 10. So here we got 2 log n plus log n, right? And here we'll get log n plus 10 log n. Okay, so here log n is a very small value. Okay, so here, right, when compared to log n, so we'll focus on the time function which is greater. So compared to these two, okay, 2 log n turns out to be the coefficient of this is larger than the second function. Alright, so here we can say n square log n is greater than n log n raised to 10. But one thing we could observe that they are asymptotically equal. Now coming to the next one, 2n and 3n. When we look into the values, we can say that 3n is larger than 2n, but they are asymptotically equal, saying that they are both of them have an upper bound as order of n. Now coming to the next example. So here it is, first function is 3n root n raised to root n, and the next one is 2 raised to root n log n. Okay, so here we are going to consider the formula of logarithmic functions, that is log a raised to b can be written as b log a. When we apply this to this function, we will get that 2 raised to log n root n. Okay, now we can see that we know that a raised to log b to the base c can be rewritten as b log a to the base c. So when we apply this formula over here, we can see that this term will come down. This is my b term and this is my a term. Alright, so my b term, that is n raised to root n whole raised to log 2 to the base 2. This will turn out to be 1. So I got n root n. Now here it is 3 times n root n. So with respect to the coefficients, we can say 3 n raised to root n is greater than n raised to root n. But when we look into the asymptotic notation, both of them are equal.